Hello, class. This will be the last of the lectures for section 3.1. And to me, one of the more important concepts there, if you're thinking about going into business, this idea of modeling your profit and your cost and your revenue. And so what I want to do here is show you the problem that we're going to do. And so I took this right out of the textbook. And in this class, we're modeling cost and revenue in this case, and then I'll show you how to calculate profit and a linear equation. And so the cost will be defined as mx plus b, where b is the y-intercept, and that's what's called fixed cost. So what is fixed cost? So say like you had a factory, in this case, manufacturing bikes. So are you renting it? Are you paying rent on the factory? Your utilities, right? Any insurance that you have, et cetera, et cetera. Regardless if you make a bike or not, you have those costs. That's what we mean by fixed cost. The variable cost is how much does it cost you to manufacture one bike? And so in this case, we've defined it as each bike costs $90 to make, and every day there is a fixed cost of $1,800. And so when we talk about equations, this would be the first one. We have C of X equals mx plus b, right? And so in this case, our m is 90, so that would be 90x, and our fixed cost is 1,800. And so that would be the linear equation with respect to this cost function. So again, you could say, well, how much does it cost you to make 14 bikes per day? And so in this case, you do 90 and 14 and plus 1,800. And then, let me double check my answer just in case I didn't screw it up. And that would be 1,800. And it looks like if you did that, it would cost you $3,060 to make 14 bikes. And the way that that's split up is this is your fixed cost, right? And then this would be your variable cost. So you usually hope that your variable cost outweighs your fixed cost, especially in a manufacturing aspect of it. And so you would hope you might make many more bikes than 14 a day with that fixed cost of 1,800. Another question you could be asked is how many bikes per day can you make if you only want to spend say $3,780 a day? So again, we just solve it the other way now, right? We have 90x and then plus 1,800. And so if you're asked that a question, what we do is we take the 1,800 to the other side. 1,800 to the other side gives us 1980, and that would be 90x. And then if we divide each side by 90, we get x equals 22. So you can make 22 bikes, and that's how much money that you would have to spend every day. So usually a good rule of thumb is you want your variable costs to way outweigh your fixed costs if you're a manufacturer. Other businesses might not work that way, but definitely in a manufacturing aspect, that works that way. So say like you make these bikes. So in a business, what do you want to do? You want to make some money, right? So this idea of how do you make money? Well, in this bike aspect of it, we need to sell them, right? So now these are being made and you go out and you say, okay, I want to sell these bikes. And you have to pick a price. And that's usually a very challenging concept of pricing. I'm not going to get into it in this lecture, but I'd love to talk about it if anybody's interested. But what I just said is, say like you decide to sell each bike at $250. So you have to generate something called a revenue equation. And typically, a revenue equation is always linear. It's like you sell something and you bring money in. And so if I sell one bike, I get $250. If I sell two bikes, I get $500. If I sell three bikes, I get $750. Sorry for the pause there. And so the revenue equation again would be very linear, 250 times X. And again, X is the number of bikes. So do we have a y-intercept in this case? If you think about it, if you sell 0 bikes, how much revenue do you get in? 0. So in a revenue equation, the y-intercept is at the origin. So if you sell 10 bikes, how much revenue do you come in? So that would be 250 times 10. And so that would be $2,500. So there is one super important number for especially for those of you starting a business, and it's called the break-even point. And what does the break-even point mean? The break-even point means that you're not losing money anymore. That's the way I looked at it for my business. I was like, hey, we made the break even. I don't have to continue to shovel money in the business right now. But the idea is that you sell enough bikes or enough widgets, in this case bikes, that your revenue and your costs are equal. That means that at least you cover all your costs. And so you're not losing money on your business. That's what we call break-even point. And so that's defined by the revenue equals the cost. So what is the break-even point for this particular business? Well, our revenue is 250x and our cost is 90x plus 1800. And so if you bring the 90 to the other side, just do this up here if you don't mind. 250, 90 minus, that would be 160x equals 1800. And you divide each side by 160. And you would get x equals 11.25. So if you end up with a fraction here, or a decimal, of course, it depends on what you want to do. If you want to make sure you don't lose any money, you always round up. So it would be 12. Or if you think about it, it could be 11 and you just lose a little bit of money. So, but you see what we mean by this decimal. You can't make a quarter of a bike. So you'd have to decide depending on what the problem states. And so a lot of things that you do is, what if you need to make more money? Well, there's two things that you could do. You could decrease cost, or you could increase revenue. You could increase the price, try to sell more. That's always the easier thing to do. But when you want to decrease cost, that's sometimes a challenge. You either want to decrease the fixed cost, which would be 1800, or try to also decrease the variable cost, which how much does it cost you to buy, manufacture the bike? Maybe you can buy the parts a little bit cheaper, et cetera, et cetera. So it's always, I worked in the manufacturing world in the telecommunication industry for 20 years. And so we struggled with these ideas a lot. It was really quite challenging and quite fun, actually. So the last thing I do want to point out is this idea of profit. And what is profit? Well, that's the much money you make. And the definition of profit is the revenue minus your cost. And you can see when you have a profit of zero, you're at your break-even point as well. And so the idea of generating this equation would be 250x is R, and then you would subtract your cost. And so when you do that, you ended up with 160x minus 1800. So what happens, how much money do you make if you sell 10 bikes? Well, we did this already, and you'll see that you would have 1600 times 10 minus 1800. And so you are going to lose 200 bucks. Because what? We're underneath our break-even point, right? Let's say like you got to sell 20 a day. So that would be 1600 times 20 minus 1800. And so when you got to do that calculation, get my calculator out real quick. So that would be 32. This is 3200. And so let's see, 1800 minus. So you would make $1,400. So you could see the value of volume, right? The more you sell, the more you would end up making, which is almost every business should be set up that way. So last thing that I do want to do is go back to Desmos here. So I'm going to pause. Okay, back to recording. So what I last like to do is to graph the cost, revenue, and profit function using Desmos and show you graphically all these ideas that we've been talking about. So let's first start with the cost, which is y equals 90x plus 1800. And again, our scales are screwed up, so I like to show you how to do that. Looks like it's back here. And so maybe we could start the x at 0. We don't really want negative bikes, right? And we could go to, say, 100 bikes. And we could start here at minus 1,000. And maybe go all the way up to 5,000. And so you kind of see we do have scales now where we can see the cost function quite well. Now remember, this is our fixed cost. So you could see at 0 items or 0 bikes, you still have to pay your rent and your utilities and your accountant and your insurance and all that other stuff. And you can see as we continue to go up here, that's when you make more bikes. So 20 bikes would be this point right here. Let's see if I can see it. There we go. Let's see. There it is, 20. So that would be $3,600 of cost when you make 20 bikes. So let's add another one and let's do the revenue this time. So the revenue equals 250x. And see, it's really nice because it changes the colors on you too. So here's the revenue. And so you can see that the revenue in the blue line, when you sell 0 bikes, you get $0. And you can see as it continues to go up. Guess what this point is? That's our break even. That's where the 2 lines intersect. And so you can see that the break even is at 11.25 bikes. So if you want more than that, you would start making money. And when you sell less than that per day, you would lose money. So let's see what the profit looks like on here. So if we do the profit, and so the profit would be y equals 160x minus 1800. This will tell you how much money that you actually make. And you can see that you make zero money, right? The green line's at zero at the break-even point, which is 11.25. And now we start making money. And so here you lose money. Here, if you don't sell anything, what do you lose? You lose your fixed cost, which is minus $1,800. So you can see we continue to go up. And so at say 20 bikes, how much money do we make? Let's see, $1,400. And so it's really nice to be able to model this because then you can get a good understanding of your business. I know my lettuce cater business, I did all this modeling, very, very helpful. I think one of the little side projects discussion boards will do is I'll give you some of those information and you'll be able to do some analysis on that. So I think this is important. So I'm pretty sure that you'll see stuff like this again. So if you have any questions on this, shoot me an email or bring it up in class when we have our Zoom class.